Good morning, my dear students. Tahir Irfan again with another video short to understand a very important chemical mechanism that is called SN1. So, what it actually is, it is nucleophilic substitution type 1, or simply we can say SN1. Please look at this organic chemical reaction. In this organic chemical reaction, you can see there is a tertiary alkyl halide that is actually tertiary butyl bromide. As you can see, a bromine atom is attached to this carbon chain at the tertiary level, and in the first step this bromine atom is getting ionized, as you can see from here, and you can see a positive charge remains. Whenever carbon is making less than 4 covalent bond, there must be a positive charge onto that. So this particular organic species called a carbocation. So you can see in the first step a stable carbocation is formed, and in the next step you see hydrogen cyanide that first ionizes to make cyanide ion by the action of potassium cyanide. Now this cyanide ion, Cn-1 ion, that is a powerful nucleophile because it attacks this nucleus that is positively charged, because this is negatively charged and this carbon is positively charged, so there will be attack from negative charge towards positive charge by showing a curly arrow, this one. So what will happen next? Obviously we will have this nitrile at tertiary position and hydrogen ion and bromide ion will remain ionized. So please let's move back to the original one. So what happens here is actually an organic molecule that contained bromine atom first ionized, making a stable carbocation, and then there was nucleophilic attack by the negative charge species on this positively charged carbon atom, making this final resultant compound. This type of mechanism that actually takes place in 2 steps. This is called nucleophilic substitution type 1. Nucleophilic, as you know, it was attacked by nucleophile. This was nucleophile, the Cn, and substitution. You remember there was bromine over here. Now Cn actually replaced or substituted bromine. So we name this a substitution reaction. It has more than one product, as you can see, an organic product and one inorganic product. So this is a substitution reaction, and this is a nucleophilic attack because Cn that was negatively charged, it had attacked to this carbon. So coming back to the same mechanism, in nucleophilic substitution type 1, the chemical reaction takes place in two steps. In the first step, this one, in the first step, there is always a stable carbocation that is formed because the halogen atom, bromine or chlorine or iodine, it ionizes and gets separated from that particular molecule. So there is a stable carbocation. This is the main point, and this is the slowest step. The first step is the slowest step, and as it is the slowest step, it will determine the rate of reaction. The next step is the nucleophilic attack that happens almost instantaneously. So that is the first step. So this is very confusing, but we must remember in SN1 the chemical reaction takes place in two steps. In the first step, a stable carbocation will be formed, and in the second step there will be attack by a negatively charged species that is called nucleophile to that particular carbon, and we will have this final product. Let's summarize that. Rx is the alkyl halide, like it can be bromine, chlorine or iodine, and HCN act as the nucleophile because it has a Cn-1 charge that has high electron density, and it can act as a nucleophile. So this is the general reaction. There was an alkyl chain containing halogen atoms, HCN attacked onto that, and you can see a nitrile is formed, leaving hydrogen halide. So the SN1 unimolecular nucleophilic substitution reaction proceeds in two steps. So as I told you, this is very confusing, but we must remember SN1 takes place in two steps. Basically, we call it SN1 because the rate of reaction depends only upon the alkyl halide. Because as I told you, the first step was the rate determining step. As the rate depends upon only alkyl halide, only one reactant, so we call it SN1, and is favored for tertiary or secondary alkyl halide. Now this is very important. Primary alkyl halides do not follow SN1 because they cannot make a stable carbocation. In the first step, there must be a carbocation formation, that is the rate determining step. Because of this we call it SN1. The general equation is over there. You can see alkyl halide, it is broken up into positive and negative charges, heterolytic cleavage, because one species took negative charge density and the other species that is positively charged. This is called a carbocation. Then the stability of carbocation follows this order. Tertiary are very stable, secondary are less, and primary they are very less. So generally, as I told you, tertiary and secondary alkyl halides can go for SN1, but for primary there will be another mechanism, SN2, which inshallah I am going to shoot in another video. Okay, the second step, nucleophilic attack. The cyanide ion from the dissociation of HCN under the catalytic action of KCN or NaCN acts as a nucleophile and attacks the carbocation. Okay, there are some key points we must remember. Number one, the reaction occurs best in polar protic solvent, for example water, alcohol, that stabilize the carbocation. Number two, tertiary alkyl halides react faster than secondary one, while primary alkyl halides do not follow SN1 due to unstable carbocations. The product is a nitrile. an alkyl chain followed by a CN, which can be further hydrolyzed to carboxylic acid or reduced to amine depending upon different chemical reactions. So we understood that SN1 is a very important chemical mechanism when it comes to the chemical reaction of alkyl halide, and this takes place in two steps. In the first step, a stable carbocation is formed, and in the next step there is nucleophilic attack. And secondary and tertiary alkyl halide, they follow this type of pattern.